Hello everybody. So let's finish today your West Bengal Public Service Commission Assistant Engineer Examination 2014 question paper. Okay, and at the very beginning of this video I would like to request you, please don't skip this video, because this video includes lots of conceptual question which may help you during the examination. Okay, so let's start with this very first question from environment. That is, you have Ca++ ion of this much, Mg this much. What is the total hardness? Well, so total hardness is given in terms of calcium carbonate, and Ca double plus is given as 40 mg per liter. That means we can express this by 40 by 20 milli equivalent. Okay, and similarly we can express Mg ion in terms of milli equivalent by dividing this 12 mg per liter by your 12. Okay, so this is coming as 1 and this is coming as 2. So the total hardness of the solution is your 2 plus 1 milli equivalent. Okay, and 1 milli equivalent is equal to 50 milligram per liter as CaCO3. Okay, so we have total hardness as 3 times 50 is equal to 150 mg per liter as CaCO3. Okay, so A is correct answer. Next is, again this is question from environment. You have two sound source, okay, one with 60 decibel and another is 70 decibel. What will be the resultant sound level? Well, 60 decibel means scientifically this is equal to 20 times log with base 10 PRMS, root mean square pressure, divided by P reference pressure sound level. Okay, and from here you can calculate that the root mean square pressure for 60 decibel is coming as your, this is PRMS. Okay, for 60 this is coming as your 60 divided by 20 and 10 to the power this one times P reference. Similarly, PRMS for your 70 decibel is coming as 10 to the power 70 divided by 20 times P reference. Okay, so what is the total PRMS? Well, total PRMS is simply PRMS for 60 decibel plus PRMS for 70 decibel. Okay, so now you can calculate the resultant sound level. So resultant sound level, let's say this is X and this is equal to 20 times log base 10 with PRMS total divided by V reference. Okay, so PRMS total is coming as this one, so this is coming as 20 times logarithmic 10 to the power 60 by 2, that is 10 to the power 3, and plus this is coming as 10 to the power 3.5. okay, VREF is cancelled, and if you calculate this it will become something like 72 point something decibel. Okay, but unfortunately in the options there is no such options 72 point something, so I don't know, but in the examination you can take this 75 as this is the closest one. Okay, but the procedure is this one. Okay, this is the process. Next question, diameter of holes for bolts or rivet less than 25 mm diameter should, while this is a question from steel, and as you have seen that in 2016 there was no question from steel, but in 2014 yes, we have encountered the very first question from steel. So for 25 less than 25 mm diameter, the hole diameter is your 1.5 plus your diameter of your rivet or bolt, and for greater than 25 mm diameter of bolt, the hole diameter is 2 plus D. So here this is 1.5. Wet mix mechanism is used for construction. Well, what is WMM? I think you have heard of WBM. Well, both of them are used as sub base, and the difference, and I'm saying this just for your interview purpose, they may ask what is the difference between WMM and WBM. Well, the main difference is that this is a product from plant, okay, or you can say that this, to make this product we have to use plant, and to make WBM you can use manual method. And next is there is slightest changes in your stone sizes, okay, or stone grading, but the major thing is WMM is used in plant product, okay. Next, constituent of road marking material. Road marking means you must have seen that when you are driving or when you travel, there are road marking like this, or at the end there is a firm yellow line, okay. So these are road marking. And binder, glass bead, titanium dioxide. Well, titanium dioxide makes the color of the road marking, whether it is white or yellow. Glass bead is the cause for reflecting your light at night, so that in the night this marking are visible. And binder, yes, this binder actually make the solution. So all of the above is the correct answer. Next, in RCC column with spiral reinforcement, minimum number of longitudinal bar. Well, this is a very typical question from RCC. For for rectangular stirrup, you have to use minimum number of 4 number of long bar, but in case of a spiral or circular section you have to use at least 6 number of bar, okay. So the answer is 6. Next, batten shall be designed to carry bending moment and shear force arising from transverse shear force B, which is how much percentage of total axial load. Well, if this is the column, you are going to design this batten or lacing, whatever. In that case, you have to take the side shear force as B is equal to your 2.5% of this axial force. So B is correct option. Next, a tank of 5 meter long and 2 meter wide and 2 meter depth. So this is 5 meter tank with 2 meter depth is completely filled with oil. So completely filled with oil, and now it is accelerated along the length. That means it has been accelerated in this direction, okay, at a rate of 1.5. so A is 1.5 meter per second square, and the amount of oil is in, well, obviously due to this acceleration some amount of oil will be spilled over. So let's find how much oil is there after this acceleration. Well, it will take some time to explain. If this is your, let's say, any tank and it has accelerated, of course the water surface will incline like this, okay. And take the free body diagram. Let's say it has made theta angle with horizon, and consider any particle. So this is the weight and this is the force which is acting towards this particle, that is m times acceleration, and W is of course m times g. G is your acceleration due to gravity. So if you draw this or complete this is theta, so this is theta, and tan theta is nothing but your MA. This is the height corresponding to this angle, and this is the base, so base is mg. So tan theta is coming as A by G. So here tan theta is, or theta is simply your tan inverse. A is how much? 1.5 divided by G is, let's say, 10, okay, and theta you can calculate it. It will come almost, I have calculated it as 8.5 degree. Okay, so it has come as 8.5 degree. So this is 5 meter and initially it was 2 meter. Okay, so what is this height? Let's mark it with red color. Okay, so this is, let's say, x, and now x divided by 5 is your tan theta. Okay, that is your 1.5 divided by 10, which gives you x is equal to how much? Well, if you calculate it, it will come as 0.75. Okay, so let's draw the picture now. The current scenario of the tank is, this is 5 meter, this is 2 meter, and here this is the condition. Okay, so this is the emptied part, this is the empty portion, and this is your 0.75, this is 5. So the total volume is remaining, the width is your 2 meter, width is 2 meter, so total volume remaining is 2 times, due to width, this area, that is your 0.5 times 0.75 times 5, okay, times 5 plus your this area, the area of this rectangle, that is simply 5 times 2. If you calculate it, it will come as your 16.2 something. Okay, but again in the option there is no such option, there is 15.2, that is the closest one, so C is correct answer. Next is, in an open channel under critical depth, what is the condition of specific energy? Well, this has been repeated again in 2016 also. So the specific energy, let's say, is expressed in x-axis, and this is the depth y. So the curve look like this. Okay, and this point is corresponding to your EC, or specific energy, when the depth is your critical. Okay, so this is the depth YC. So of course here you can see that specific energy is minimum, so yes, B is correct answer. Next, maximum area of compression reinforcement in doubly reinforced beam of width B and depth D. Well, this may create a quite confusion, but yes, this is 4%. Okay, so D is correct answer. For singly reinforced section, the total percentage of this tensile reinforcement is 4%, but for a doubly reinforced section, for both compression and tension, they are 4% and 4%. That means total of 8%. Next, the total distributed load on purlin is W, including wind load. The maximum bending moment is, well, this is taken as your WL by 10, total weight or total load times the span divided by 10. Okay. Next, this is a question from fluid mechanics. A stream function phi is given, and you have to find the magnitude of velocity at a point or at this coordinate. Okay, so you know that if this is x, this is y, then if we take derivative of this stream function with respect to x, okay, we will get the velocity in the direction of y, that is by, and if we take the derivative with respect to y, in that case we will get this one. So this represent your velocity in x direction but in negative direction, so this is minus px. Okay, so p, your stream function is given as 4x cube minus y square. Okay, so py is coming as your 12x square, and px is coming as your y, so minus 2y. That means Vy at this coordinate is 12 into 1, that is 12, and Vx is coming as your minus 2y. Sorry, this is 2y and this is 4. So velocity at this point is simply square root of Vx square plus Vy square, which will give you 144 plus 16, that means square root of 160. So this is in between your 12 and 13. Okay, so yes, B is correct answer. Next is the ratio of average velocity to maximum velocity for steady laminar flow. Well, this is simple. V average is always half times of V max. So the average divided by your max is coming as 0.5. So C is correct answer. Next is main function of alumina in brick. Yes, to impart plasticity. This is a memory based question. So always when you are studying the component of cement or brick, okay, try to study also the function of this component. That means alumina, silica, whatever may be the component for in case each and every cases. Okay. Next is, in case of pre-tensioning, tensioning force should be applied gradually, quickly, in step, none of the above. Well, if you ever have seen the pre-tensioning process, well, after casting the girder, okay, there are lots of tendon. Okay, the tendon have gone like this. Okay, and they may be tensioned from one end and anchored in other, and the tension is applied sequentially. Well, this sequence need to be also designed, so they never happen quickly, neither they are given gradually. Okay, step by step the tensions are applied in each and every tendon. So C is correct answer. Okay, next is your sag rod. Sag rod in hook truss are used for connecting. Well, if you don't know what is sag rod, if you, let's say this is the plan of the roof, this is truss, so of course there are purlin like this. Okay, and this purlin may be subjected to your lateral forces. Okay, the lateral forces may be applied anywhere, maybe due to wind or maybe accidental. So this may buckle like this. So to prevent this buckling, what we do, we simply provide a sag rod like this, and we connect them with the truss. So the lateral load travel through this tie or sag rod, and then through this bracing they transfer to this main truss. Okay, so they are used for connecting your purlin. Next is the slenderness ratio for single angle discontinuous strut shall not exceed, this is also 180. And here you have seen that this, the previous one which I have just discussed, sag rod, and this slenderness ratio both are from steel. So in 2014 I think lots of total 3 questions has come from steel. Well, next is, in which of the following types of flow the losses are maximum? Laminar flow. Well, the losses in flow is due to the formation of eddies or vortex, whatever you can say. In case of laminar flow it is less. In case of critical flow it is quite higher than laminar, and then in case of transition flow this is more, and this is highest, or this eddies formation is highest in case of your turbulent flow. Okay, so losses is maximum for turbulent flow. Tranquil flow must always occur. Again, this is a question from your open channel flow, and you know the tranquil flow that occurs at the depth more than, let's say this is the depth y normal and this is the depth yc critical depth, and this is the tranquil zone. That means if the normal depth is more than critical depth, so above critical depth. Okay, next is your compressive strength of any structural concrete sample should not be less than the specified characteristics. Well, the acceptance criteria says that the minimum should be FCK minus 3 when the strength is up to M15 and FCK minus 4 for M20 and above. Okay, and here there is no option 4, so 3 is there. We can say that, or we can assume the question is based on M15 concrete, so B is correct. Next is the aerobic environment nitrosomonas convert. This is covert. No, this should be convert. So the main function of nitrosomonas is to make sure that nitrification happen, and in nitrification you know that ammonia converted into nitrite. So A is correct answer. Next, sewage treatment in an oxidation pond is done by, well, this is also a typical question from environment. So in sewage treatment, when it is done in oxidation pond, what happened? You have some organism and you have some food or organic matter. Okay, so what will happen? This organism takes this food and they use oxygen for their respiratory. But who will supply this oxygen? Well, there are some algae. Okay, algae are green and they can produce your oxygen by the process of photosynthesis. So they produce this oxygen, and in return the carbon dioxide which are produced by this organism is taken by this algae. So there is a symbiosis process. So option C is correct, algal bacterial symbiosis. Okay, next is your combined flakiness and elongation indices of coarse aggregate for WBM. Well, this is 30%, 35%. This should be less than 35%. And here I'm not sure which one is correct, A or B, because it is saying 30% and it is 40%. But as per MORTH, this should be less than 35%. And also in PWD road schedule, 35% is taken as the limit. Okay. Last one is photochemical smoke is caused while in megacities when there is your NO and the hydrocarbon emission from your vehicle and the cyanide, that means you have ultraviolet ray. So in the presence of this ultraviolet ray, they react and produce your NO2, ozone and peroxyacyl nitrate or PAN. Okay, and they create an hazy browny environment that is known as your photochemical smoke. So is caused due to hydrocarbon and of course sunlight. C is correct option. Okay, and I think I have missed a question, or I have forgot to copy it, and let me finish with that question. I think I missed your 85 number question. So in between 84 and 86 it should be there, but I have forgot to copy it. And well, let me describe it. So the question is, it is there that in your air there is 470 microgram per liter your nitrogen dioxide concentration. Okay, and you have to express this in terms of your ppm. And you know what is ppm? ppm is your parts per million. So you have to express this microgram per liter to ppm. Okay, and this concentration is at the temperature of 25 degree centigrade. Okay, so this is a very good conceptual question from environment. So please stay focused, and after this question I will finish this video. So ppm means there should be something 1 parts or some parts per million parts, or here should be your x in million parts or 10 to the power 6, and here it is given as microgram per, of course this is meter cube, not liter, meter cube, per meter cube. Okay, so here should come meter cube and also here meter cube. Okay, So at the denominator there is already meter cube, that is already given in meter cube. So we need to convert this microgram into your meter cube. So how to do that? Well, you know that any gas under STP or at 273 Kelvin temperature with your standard atmospheric pressure has a volume of 22.4 liter, and of course for 1 mole. Okay, and here the temperature is 25 degree, that means this is 290 25, so 298 Kelvin. So for 298 Kelvin, by using this formula PV is equal to nRT, we can say V by T or P1 T1 is equal to V2 T2. So at T2, what is the volume V2? It is coming as T2 times V1 by T1, or it is coming as 24.5 okay liter, and this is for 1 mole, and the mass of 1 mole nitrogen dioxide is simply 14 plus your 16 times 32, that is your 6 and 4 46 gram. Okay, so or we can keep it in your gram. So for 46 gram of nitrogen dioxide at 298 Kelvin temperature, we have 24.5 liter or this meter cube volume. Okay, so for 470 microgram, or we can write 470 times 10 to the power minus 6 gram, we have 24.5 times 10 to the power minus 3 times 470 times 10 to the power minus 6 divided by your 46. This is the volume. Okay, now calculate it. You will have automatically this will come down, that is 10 to the power 6. Okay, and now you can remove this meter cube. So this is 10 to the power 6, and here is 24.5 into this is 0.47 and divided by this is 46. So at the bottom this is 10 to the power 6, and if you calculate the remaining one, you will get 24.5 times 0.470 divided by 46, and it will give you 0.250. So this is part per, this is million. Okay, so now we have converted, it is coming as 0.250. So this is equivalent to your 0.25 ppm, and in the options, yes, there are 0.25. Okay, sorry, I forgot to paste this question, and the question is that you have nitrogen dioxide concentration in air with 25 degrees centigrade given in this format, and you have to convert it into ppm. Okay, and this is a typical question which also come in your GATE question also. Okay, so that's all. We have completed 2014 question, and in the next part with all your requests I will start 2012.